Alright, before we go any further in our differentiation rules for transcendentals, I think it's important that we refresh our memories a little bit on some properties and notation that goes along with exponential and logarithmic functions. So the first thing you got to make sure you're able to do is, if you have an exponential statement, which would be something along the lines of this. Just get my pen going here. So this would be an exponential statement where b is just some number. So for example, 3 to the x, 5 to the x, whatever it may be. You should know how to switch that to its inverse. So the logarithms are inverses of exponentials. Again, I'm not reteaching you logarithms. We did cover it in pre-calculus 12a, but it is important, I think, that we just refresh your memories on some of these properties because it's been a while. So as I said, to get to the logarithmic version, it is the log of y to the base of your exponential, base b, will equal your exponent. So it's that connection that we make that logarithms, so someone says, what are logarithms? Well, logarithms technically are means of finding exponents. Right? Because if you look here, x is your exponent. When I found the log of y to base b, it turned out to be x, which is my exponent. So for example, if I have the log of 17 to base 3 equals w, that would imply that 3, this base, to this value, will equal 17. So if I said, what's the log of 25 to base 5? This is saying 5 raised to what exponent will give me 25? The answer would be 2. Right? 5 squared equals 25. So that's the first thing that you should be comfortable with, is how to switch back and forth between logarithmic and exponential notation. There are 3 what we call basic properties of logs that we expect students to be familiar with when they get to this point in their studies. The log of 1 to any base is always equal to 0. And again, if we understand the properties of logs, if I said the log of 1 to base 7, what I'm asking you is 7 raised to what power will give me 1? Well, based on our knowledge of exponents, we know that any base raised to the 0 always gives us 1. So that's how I know that the log of 1 to any base is always equal to 0. This second one, it says if you have the log of a base raised to an exponent to the same base, the answer has to equal that exponent. Well, this is really self-explanatory. This is, if I have log of 7 to the 4th to base 7, this implies 7, right, your base, raised to what exponent, assuming I didn't know this for, equals, this is called the argument of your logarithm. 7 raised to what exponent gives me the argument 7 to the 4th? Well, it's got to be 4. Right? So if I had the log of 2 to the 5th to base 2, without knowing a whole lot about this and understanding this property, this means 2 raised to what exponent gives me 2 to the 5th? Well, my answer would have to be 5. So as long as this base and this base are the same, the answer will always equal that exponent. This third one isn't used as frequently, but it is a property that if you have a base and your exponent is a logarithm that's the same base as the base of your exponential, it has to equal this argument. So for example, 7 to the log of 15 to base 7, it's got to equal 15. This is saying 7 raised to this exponent, which is a logarithm that's also base 7, based on this property, has to equal 15. And again, I'm not getting into the proofs and derivations of all this stuff. We did that before. I'm just trying to refresh your memory on the properties. So if you wanted to dig more in depth in these, you could certainly find further information to explain why this in fact is true for all of these. Alright, so in addition to your 3 basic properties, you would be expected to know what are called the 3 laws of logarithms. There is what's called the product law, which is when you have two logs, same base, added together. You can write it as a single log of that same base as a product. So for example, I had the log of 7 to base 3 plus the log of 5 to base 3. That would be the same thing as finding the log of 35 to base 3. Right? Sum, same base. You can write it as a single product of those. Put that back here. Quotient law. Nice thing is these pretty much parallel with laws of exponents. If you have the difference of two logarithms, both in this case base, I use b as an example, but it's generic as long as they're the same, then you can write it as a single log of a quotient. So for example, if you have the log of 24 to base 5 and you subtract the log of 8 to base 5, that would have to equal the log of 3 to base 5. And you say, well, how'd you get 3? Well, 3 would be because it would be a single quotient of 24 divided by 8, which is equal to 3. And the final one is called the Power Law of Logarithms, and this is used when you've got the log of an argument raised to an exponent, and now this time the base is not the same, so don't confuse it with the property we did earlier where this was a b and this was a b. This one now says you can bring that exponent out to the front and write it as a product, so c multiplied by the log of a to base b. So an example of this would be log of 10 to base 4. Let's say that was to the third. I would be allowed to write this as 3 log of 10 to base 4. That's called the Power Law of Logarithms. And then the final formula, I guess we'll call it, that I would encourage students to be familiar with is one called the change of base formula. This is very useful, especially if you've got a calculator that doesn't do any base you wanted. This is how you would change from, let's say, whatever base you're in, b, to some new base that you would choose. Let's say in this case I used j as an example. Well, what you do is you take the log of your old argument to your new base, and then you take the log of your old base to your new argument. For example, if I had the log of 170 to base 5, which means I'm trying to figure out 5 raised to what power gives me 170. My calculator won't do base 5, so what I'd have to do is use a formula to change it to, let's say, base 10, because my calculator will do base 10, so I could go log of 170. When you don't put a base here, it's understood you're talking about base 10, and then I would divide by my old base, which was 5, also to base 10, and then I could just throw that in my calculator and it would tell me 5 to what power would give me 170. So this is a really useful formula for you to know. Okay, so that's just a quick crash course in all of the formulas and properties that you should be familiar with for exponential and logarithmic functions as we start to dive into how to do the derivatives of these types of functions, and some of these properties will get used throughout. Alright, thanks for watching.